Hello, everyone, and welcome to a new exciting webinar. My name is Marcela Valverde, and it's an absolute delight to be here with you alongside our esteemed speakers, Roger and Gregory. Before I hand it over to them, I would like to go highlight just a few key points. Your voice matters. We are eager to hear from you. If you have any questions, please share them in the chat box below. Our dedicated team is committed to addressing all of your questions. And in the rare event that we are unable to cover all of your questions, rest assured we will respond via email. Expand your knowledge. We have curated additional resources for you to explore. Feel free to delve into those valuable materials as they will undoubtedly enhance your expertise. Give us your feedback. We want to hear from you. We want to know how can we do better and give you greater content. Without any more delay, I now hand it over the torch to Gregory and Roger so they can continue to enlighten us.
So, hello everyone. Let's introduce ourselves. I'm going to start by myself. I'm Roger Freixa. I'm the Senior Director of Engineering for RabbitMQ and other VMware data solutions. And presenting with me have Gregory Green. Gregory, would you like to introduce yourself?
Hey, hello everyone. Gregory Green. I am a solution engineer based out of the United States in North Carolina. I have the privilege of advocating how cool our data products are to customers. So it's a pleasure to be with you today.
Thank you, Greg. Let's move forward. Today, we are going to talk about RabbitMQ Streams, right? But before starting on RabbitMQ Streams, let's talk about what is RabbitMQ. RabbitMQ is one of the most popular message brokers in the industry. It is used worldwide at the different types of companies, from startups to Fortune 1000 companies. What makes RabbitMQ a very popular solution is that it's lightweight and can be easily deployed on premises or in any public cloud. Runs atop of many different operating systems and cloud environments, and provides a wide range of developer tools for most of the popular languages. However, one special capability of RabbitMQ is that supports multiple messaging protocols along with streaming. On this webinar, we are focusing on streaming capabilities as part of RabbitMQ. So, what are streams in RabbitMQ? Streams is a type of data structure that enables RabbitMQ to become an event streaming platform, reusing the simplicity of management, the scalability, and the performance, which are the fundamental constructs in RabbitMQ. Specifically, a RabbitMQ stream models an append-only log with non-destructive consuming semantics. That means that as opposite to the traditional queues on RabbitMQ, consuming from streams doesn't remove messages. In other words, streams in RabbitMQ are persist and replicated. So data is safer and available in the case that one of the nodes goes away. That also allows to provide additional scalability capabilities. The same stream, for example, can be read from multiple nodes. So it supports horizontal scalability. Another important aspect is that RabbitMQ Stream internal implementation uses its own binary protocol. But at the same time, streams are interoperable with other protocols like different flavors or AMQP like 0.9.1 or 1.0, or STOMP or MQTT, for example. So what are the strong points for RabbitMQ? Well, the first one is mentioned here, large fanouts, right? So In case to deliver the same message to multiple consumers, using the RabbitMQ classical queues, each consumer must have a dedicated queue. If the number of consumers is large enough, this becomes potentially inefficient, right? Especially when persistent or replication is needed. Streams allows any number of consumers to consume the same message from the same queue in a non-destructive manner. That means that consumers doesn't have to have a bind to multiple queues. The stream consumers will also be able to read from replicas, allowing to increase the throughput across the cluster. That is especially important. Another strong point is replays, right? Traditional RabbitMQ messages are deleted from the queue when a consumer is finished with them. But it's not possible to reread the message that have been already consumed. The streams allow consumers to attach at any point in the log and read from there at any time. Another important factor is high throughput. This is especially relevant on event streaming platforms. RabbitMQ is able to deliver throughputs that can compete with any of the existing log-based messaging systems in the market, as you will see later on the section that Gregory is presented. Streams has been designed with performance as a major goal. And finally, large backlogs. While regular RabbitMQ queues are designed to converge towards an empty state, RabbitMQ streams are designed to store larger amounts of data in an efficient manner with minimal in-memory overhead, and all this without having external storage management on the solution. So why streams in RabbitMQ? That's very relevant because what we've found over the years is that when you try to build an EDA, an event-driven architecture, using any of the products of the market, the two paradigms, traditional queues or messaging brokering, where the queues are eliminating the messages once consumed, or streaming capabilities, are use cases that coexist, right? So we decided that putting both paradigms together on the same platform will minimize the operational requirements to run a proper EDA solution. So we always have seen that these two types of messaging models are complementary. At the same time, it's relevant because it allows us to have a proper foundation for future capabilities. For example, right now, RabbitMQ is available for the whole Spring ecosystem, Spring Boot, etc. RabbitMQ Streams is also available for all these Spring integrations that we already have. And in addition, we are extending integrations in several areas, especially on a Spring streaming new frameworks that will help on simplify the messaging and streaming platforms. So let's talk about use cases for RabbitMQ Stream. So financial services, a typical microservices implementation where RabbitMQ Streams can play a significant role on processing billions of events, covering millions of transactions. That's a relevant use case on the microservices wall. On the automotive world, IoT is becoming an interesting journey, right? Capturing the events coming from one vehicle, where a lot of these events have not the best conditions to be streamed or to be connected to a central hub, That's another very interesting area for RabbitMQ. And finally, commerce, right? On edge installations, and not only in commerce, in industry, where you have to have simple installations that can operate standalone without having to have a lot of assistance, RabbitMQ is the perfect solution. In all three use cases, what is relevant is that the solution doesn't have dependencies on an external consistency store. We already have implemented this on the product, along with support for multiple protocols adapted on the industry that our users or customers are engaged with. From MQTT, like I mentioned before, which is relevant on IoT, to AMQP 1.0 for Edge or for traditional messaging structure with a stomp or other types of messages. And it's relevant because all this is supported by a wide variety of clients and languages that best adapt to the needs of each industry. So let's go to the technical insights. Gregory, over to you.
Okay, great. All right. Developing with RabbitMQ Streams, maybe since the beginning, which was first introduced. And obviously, I am a fan of Streams for the features that it includes, but most importantly, as Roger mentioned, for the performance gains that you get with Streams. So you, as a potential customer out there, maybe you're watching the webinar and you are excited about the possibilities that Streams may bring to your existing messaging needs, but maybe you're concerned about the level of effort to incorporate Streams. So I got some really good news for you. As Roger mentioned, your existing applications that are talking to Rabbit today using AMQP, you can have those existing applications utilize Streams with low effort. All you need to do is make sure that you upgrade your RabbitMQ version at the time of this recording. The latest version of open source RabbitMQ is 3.12. So a stream in the RabbitMQ cluster to an AMQP client just looks like a normal stream. And actually, with the latest versions of Rabbit, you can set the default queue type such that when your applications create a queue, it'll create a stream by default. But if you have the luxury of actually going in and changing some of your AMQP client code, creating a stream from AMQP is just as easy as setting an argument when you declare the queue. You basically just set the queue type to a value of stream. And your consumers can benefit from the replay capabilities of Rabbit. So, for example, and this is on the lower left-hand side of the presentation, just an example, AMQP-based code to read records from the offset of 0, which is basically the beginning of a stream. Now, obviously, in order to get the full benefits of Streams, you should consider, especially if you have the luxury, to onboard the new streaming APIs. So I want to say that Streams was first developed, I think, in 2021, 2 years ago. And the first version of the client API was Java. But since that time, the Rabbit team has provided a Go client and a .NET and Python and Node.js and a Rust-based client. Now, the APIs basically just look like this. On the right-hand side, you see some coding examples. There is an environment object. The environment object sort of it acts as the connection for a stream, and you can create streams. And your consumers, for example, if they wanted to do the equivalent that you saw for the AMQP example, if they wanted to read from the beginning of the stream, they basically specify an offset. In this case, we're setting the offset specification to first, basically reading from the beginning of the stream. And then you can provide your message handler implementation. So whenever you get a new message on the stream, RabbitMQ will call your code. And you could do things like publisher confirms and consumer acknowledgments. Moving to the next slide. Now, for your developers that are concerned with data safety, again, I got more good news about the reliability for RabbitMQ Streams. Actually, I'll just say in general, I have lots of good news with this webinar. You probably wouldn't attend this webinar if I had a whole bunch of bad news, right? But again, if you need some guaranteed delivery within streams, Rabbit Stream supports at least once guarantees, right? And again, as I mentioned before, you get publisher confirms and acknowledgments, but publishers can publish to a leader node within the cluster, right? So for each stream will designate at least one and only node to be the primary. But you can also define a number of replicas, and it's totally up to you on how many replicas you need for your data safety requirements. But your consumer applications can consume directly from the replicas, and you can scale up. You can improve your scalability basically by adding more streams to the cluster, and you should balance out the leadership of the different streams across different nodes within the cluster. What I mean by that is it should never be a case where if you have a three node cluster, all of the leaders are on one node, right? You basically want to make sure the leadership is spread across the different nodes, and that's how you get the improved throughput. All right, so next slide. Also, if you have an application, a producer application that is just from the nature of the data, it produces a lot of duplicate data. Again, more good news. Rabbit supports it can basically clean up some of those duplicate messages for you. All you need to do as a publisher application is set your publisher name, and you specify a unique ID with each one of the messages, right? So for the same publisher name with the same ID for the message, Rabbit will see that it's a duplicate and remove again some of those duplicate messages, which can be it's got multiple benefits. One of the benefits is that you have less data that you have to manage on the cluster, right? So you can save some storage size for duplicate data, but also you can reduce some of the needed duplicate processing within your consumer application. So pretty cool, I think. All right, the other feature is something called sub-entry batching. So RabbitMQ Streams by default supports batching, and the default batch size is 100. What that means is if I publish messages, if I send 101 messages, right, those messages will be sent immediately from the client, from the publisher to the broker once I hit the batch size. And there's also a delay. So for example, if I send just one message, it will wait. I believe the default delay is 100 milliseconds. So it'll send it based on the delay or based on the batch size. But it sends those messages individually. You can set the sub-entry size, which is basically sends multiple messages over the network as a package, so to speak. So this can greatly improve the throughput for publishing messages and consuming messages, especially if your network supports higher bandwidth. But you do need to be careful because it can increase the latency for those use cases. But also, when you're using sub-entry batching, you can combine that with using compression. So now, since you have a larger payload size that you're sending with your sub-entry batches, you can use any one of those compression options that are outlined on the screen to reduce the payload, right? To optimize the network utilization, but also that data is going to be stored on your disk in a compressed format. So again, you have some storage optimization also when you use compression. When RabbitMQ Streams was first introduced, the way that you had to increase the parallelism is, as I mentioned before, you could think of as one stream, almost like a partition. But I couldn't necessarily have multiple consumers. And if you're familiar with the traditional terms of RabbitMQ, we have basically consumer groups. So I can basically add more consumers point into one queue, and that would increase the throughput of processing messages on a single queue, right? That wasn't traditionally supported within Streams when it first released, but now it is. So now we have a feature, the team has developed a really cool feature, which is called super streams. With a super stream, essentially you can define, it's almost like a logical stream, and you can create a super stream and you configure a number of partitions. So in this illustration, I have a super stream with 3 partitions. And what happens behind the scenes is the publisher clients basically uses topology information to route messages based on a routing key to one of those streams in those partitions. And when I'm using the same routing key, basically the same routing key will always be routed to the same partition. Now, with this case, now I can have consumer groups. So basically I can create a single active consumer group, and each active consumer will own one of those partitions or one of those streams. So in this case, when I have 3 consumers, all part of the same group, they basically have the same consumer name. 3 of them are going to be active, and because they will own one of those 3 streams. And my 4th one will be inactive because, again, there could be only one active. But if there's ever an issue with one of those consumers, then the inactive one would kind of step in and become active. Let me give you a demonstration. So let me go ahead and share my screen. All right, I hope you should be able to see my screen. All right, so what I have is I have a shell, and I have 3 tabs on my shell. And then I have a producer application that's sending some data to a superstream. So the routing key for this example is this ID. So I did some testing before the webinar started. In this case, all of the IDs that have the value of 6 are routed to the top node. So let me go ahead and send some data. So you see that just got routed to the top node, and so on and so forth. So every unique ID is always routed to a particular consumer. So for example, this one has the number 7. So 7 will be routed to the one in the middle. And then at the bottom, if I use the ID of 4, it's routed to the bottom, right? So again, I didn't have to code how the data is actually routed. The superstreams functionality handles all of that for me. Let me go back to the presentation. Okay, and screen share. Okay, great. Let's go back to the slides. All right, I don't see the slides. Hold on.
I activated for you, Greg.
Okay. It's taking a while to show on my side. Just give me a second. But again, I hope that you see the potential of now using super streams for doing parallel processing. Now, a newer feature is coming soon. The latest, as I mentioned, the latest version of RabbitMQ is 3.12 and 3.13, again, which is already a candidate release version. The team has implemented filtering. And what filtering with streams allows you to do, in this case, you can set a filter value. And the consumers, before filtering, every consumer basically had always received an exact copy of every message that is sent to a stream. But now with filter values, consumers can register, basically telling the cluster which messages that they're interested in, and the cluster will only send them those. So there's some filtering happening on the server side. There's also some filtering that can happen on the client side. But I could also tell the cluster if there are any messages that have not been published with a filter value. I can also basically register interest with those, with the convention where it says match unfiltered records. So I'll dive into some of the use cases that also opens the door to. But again, some really cool features that have been added to the product. Now, as Roger mentioned, and as I'm having a lot of conversations with customers, my customers are really excited about the possibility now of using traditional message broker use cases, right? Where I'm just using the RabbitMQ that you've been using in production for years and you've had little to no issues with, using all of those protocols that were mentioned that's supported by RabbitMQ, like AMQP, which is the default protocol, or for Internet of Things, MQTT, or for legacy, J2EE based applications, or even mainframe applications that want to utilize JMS or HTTP and using Stomp interfaces, right? I can now combine all of those traditional use cases with streams, right? So whether I'm using an exchange, I can use a single exchange in this example and have routing rules that route to traditional MQTT consumers. You may know that with version 3.12 of Rabbit, there was a feature called native MQTT, which basically dramatically improves the performance for having a large number, like millions of connected devices to a Rabbit and using a new queue type, which is basically an MQTT queue type. But also you can combine that with classic queues and quorum queues for high availability, right? So in this example, I'm routing to one of those queues, like Canada's is an MQTT client, or US is using classic queues, or APJ is using quorum queues. And then I can have every single message routed to streams for doing things like auditing or analytics. So I wanted to shift gears to start talking a little bit about performance. Now, before I go into performance, I will say that to get higher throughput for performance, the normal factors are in play, right? Because Rabbit is a distributed system. It's going to be impacted by the throughput and the proximity between clusters and clients. It's also going to be impacted by the number of cores that you have for each one of those broker nodes. But I will say that streams is sort of like the traditional, what we call in Rabbit, a lazy queue. Now, lazy queue sounds negative, but it's not negative. It basically means that it's going to be persist to disk first, right? So it minimizes the impact of memory usage, especially when you get those large batches of data, right? So that's how it's able to get high availability, even with higher throughput of data, right? So you want to make sure that you have a performant disk, like an SSD disk, because that's going to, again, impact your performance. And you could do things within RabbitMQ like provide a retention policy. So, for example, you can keep as much data as you need, but you can also define how much data. You can optionally define how much data you're going to store for each stream. So, for example, you can define a retention policy of storing only 2 weeks worth of data, or a couple of months, or a couple of years worth of data based on your requirements. All right, so now this is some of the publicly available benchmark numbers for streams, just illustrating for typical message size. You see the message rates in the throughputs in terms of the number of messages per second, right? With one stream, you can easily get over 1 million messages per second. But also, as I mentioned, you can improve the scalability by spreading that load across various different streams. So for 5 streams, for example, the team almost got 5 million messages per second. And now that Rabbit has super streams, spreading that load across multiple streams is just made easier. But as I also mentioned, you can combine streams with sub-entry batching. So in this particular example, when they started to introduce a sub-entry batching for one stream, they got over 4 million messages per second. But then when they increased that to 5 streams, look at that, almost 17 million messages per second, right? Now, often when we start talking about performance, I get this question of, well, how does that compare to this technology or that technology in particular? How does it compare to Pulsar or Apache Kafka? Now, I will just say that the team is confident that Rabbit is now comparable in performance with each one of those for other technologies that are in the industry, right? But don't take my word for it. Please try it out for yourself. There is a public repo. In the public repo that I provided, right? Here's the link. You can use the QR code to open up to get to get a link to the repository. In that repository, it basically just tries to it generates 2 million records, transactions data. You see the data attributes that's being used in this test. And it basically just tries to publish it as fast as possible. It's based on a Spring Batch. It tries to publish it as fast as possible, either into RabbitMQ or into Apache Kafka, right? And it basically gives you a report of the differences between the two. Now, again, for this repo, if you look at that repo, I gave some initial benchmark numbers that I got on my local machine. But again, as I will reiterate, don't take my word for it. Try it out for yourself to see if Rabbit provides comparable performance. So now I want to dive into some of the use cases for that RabbitMQ Streams provides. It's sort of double clicking into some of the use cases that Roger highlighted at the beginning of the talk. So as Roger mentioned, now combining, protocols like Internet of Things protocols like MQTT, where your robots or your devices or your sensors, right? They just need an MQTT broker. So Rabbit can act as an MQTT broker, and you can combine streams so on the top. For example, you can route messages based on topics that are specified in the MQTT publisher. You can write some of those or all of those messages to a stream or a super stream. So you could have newer applications that are interested in processing that data at higher volumes and using some of the replay capabilities, some of the filtering, so on and so forth. But you can also combine that with the traditional clients that may be using AMQP for tapping into some of that data, or even MQTT for consuming some of that data. Now, this particular use case is it's inspired by a conversation that I've had with a couple of different customers, right? So, for example, suppose now there's a larger number of devices. Suppose you want to get all of the events across many different homes, maybe millions of homes or thousands of homes, getting things like the current state of a door being opened or closed or a window being opened, right? You can send all of that state information over AMQP to support millions of clients, right? Especially when you're using the latest version of Rabbit with the upgrades or the improvements that they made to the MQTT protocol. But now you can combine that with super streams and filtering. So, for example, suppose you have a monitoring application that they just need to get all of the events, right? In a simplified manner, right? So they can use super streams and have auto parallelism across the different partitions. Or if you needed to send all of that information to basically get at a user level, maybe there's thousands of users or millions of users, right? Uh, before streams, you had to have an individual queue to have ordered events for a particular user. But now that you have streams, you don't have to do that, and especially you can use filtering, right? So I can have a number of partition streams, and the filter can correspond to a user or even a priority. So suppose there's a there's a break-in event. Somebody is trying to break into the house, right? And the device, the alarm goes off, so the device knows that this is a break-in event. Well, the device can just send in the payload, right? It can just send as a higher, it can send a filter value with a higher priority, and then you can have specialized apps that are quickly just concerned with these alarms or these warnings. So again, just the opening up the door for the possibilities that you can now have with streams. In addition to Internet of Things connected cars, right? I've been saying this many times. There has been an explosion in interest of machine learning, artificial intelligence workloads. So, but you can now combine streams with doing things like real-time inferencing. So suppose this is an example. Maybe you're doing fleet management and you want to do predictive maintenance or predictions for cars, right? So maybe the cars are sending telemetry information to a RabbitMQ cluster. Things like you not only know the make, the model, the tire brands, but you're also knowing things like the distance that is traveling, the mileage on the car, the temperature of the engines, and so on and so forth, right? So if you have some sort of model, right, you can have an inference-based app that is tapping into the telemetry information in real time. And you can run that data, that telemetry data from through a model. And if the model predicts with a higher probability that, hey, you know what, it's very, very likely that this particular car would need some sort of maintenance, right? You can set a filter value, right? And that filter value can be, you can have a designated system that basically is looking for those particular cars that need maintenance, right? So again, just another possibility of a use case that's open, that the door is opened up with using streams. The last use case that I wanted to highlight is, as the slide highlights, is something called data virtualization or a single pane of glass. I've been having conversations with customers, and this is sort of very interesting for those who are trying to turn data into a product, right? So there may be cases where, for example, accounting data, for example, maybe it's replicated in many different systems. Maybe there has been, over the years, there have been several ETL jobs to copy data from one microservice to another. And then since it's been implemented as a project and not as a product, there may be some questions on Who owns that data, right? So maybe you want to introduce something like a data mesh, where you designate a single team to own a particular domain, whether that's orders that is managed within a relational database like VMware Postgres, or inventory data that's managed in VMware MySQL, or accounting data that's stored in a NoSQL database like Gemfire, or telemetry information that also uses MLAI data at scale that's stored in a massively parallel processor database like Greenplum, right? And if you want to, you have many different applications, they are interested in getting at this data, right? Now you don't necessarily need to have an ETL for each one of those applications. Just put all of that data into a stream. And when you onboard a new client application, they basically become a new stream consumer, right? So they can get all of the data since the beginning of time, but also that as changes happen, right? Updates to the events come into Rabbit, right? You can use the stream so that all of those client applications are always kept in sync with the latest and greatest version of their data, right? So again, it's just another way to facilitate or easily replicating or using data as a product for your various data domains. All right, so I think that's it. We're going to open it up for questions that you may be having.
Looks like we have a quiet audience today. Roger and Greg, not sure. Come on, people. Go in the chat box. Let us know any questions that you have. We're eager to hear from you so we can answer any questions. Looks like we don't have any at the moment. So Roger, Gregory, any closing remarks you want to do? If not, we can close the webinar.
Thank you, Marcela. I think as a remark that I would like to make at the end of the webinar is that RabbitMQ Streams provide an additional model to model your applications, as Greg mentioned, that you don't need to have additional infrastructure installed, right? Your existing RabbitMQ could potentially uptake in these stream use cases and become your complete EDA platform for all the requirements that you have. That's essentially the lesson for today. Greg, I don't know if you want to add something else to that.
Yeah, I just want to say, please don't hesitate. If you want to kick the tires on RabbitMQ, please reach out to us. You can find us on LinkedIn. So yeah, we're looking forward to hearing about your use cases and seeing if RabbitMQ is a fit. I would say that most people that I've talked to, they absolutely love it. So we want to get more customers, and we're just spreading the awareness. So looking forward to chatting with you out there in the community.
Thank you. Thank you guys for your time. Appreciate it. Thank you everyone for this time with us. Again, contact us at any time. We're here for you. And with that, I'm going to go ahead and close it just to remind you that this has been recorded and will be posted right after the event. Thank you and have a good rest of your day. Bye.
Thank you.